Alright, so in this video, we're gonna discuss some basic probability. Alright, so when we talk about probability, well, we are going to discuss the naive definition. Naive definition of probability. And basically, this means that the probability of an event A. So A is an event, is the probability of event A happening is equal to the number of outcomes favorable to A divided by the total number of possible outcomes. Alright, so another way to write this is that I will say it's n of A, which is the number of outcomes favorable to A, divided by T, which is the total number of outcomes. Alright, so the probability of A is the number of outcomes that are favorable to A divided by the total number of possible outcomes. So what do I mean? Let's see, I have a dice, right? Something like this. I have a dice, and I want to know the probability that I roll a number that is even. Alright, so probability of an even number is the number of outcomes that are favorable, right? So the number of outcomes that are favorable to rolling an even number divided by the total number of possibilities. Well, if you roll a dice, what are the total number of possibilities? You can roll a 1, you can roll a 2, so you can roll a 1, 2, 3, you can roll a 4, 5, 6. So there are 6 total possibilities. And how many of these possibilities are favorable to A? So the A is that the number is even. So you can roll a 2, which is even, 4, which is even, 6, which is even. So the number of favorable possibilities is 3. All right. So now you know that it's just 1 over 2. So that is how you apply the naive definition of probability. All right. So now that we know that, well, another way to think about this is that, hey, well, rather than saying counting the number of outcomes favorable to A, I can say that, hey, number of outcomes favorable to A plus the number of outcomes that are not A, right? So number of favorable outcomes, number of outcomes that are favorable to A, and the number of outcomes that are not favorable to A, if you add them together, you should get the total number of outcomes, right? So n of A is just T minus n of not A. All right, and we can substitute this into the numerator here. So I can write this as T minus n of not A divided by T. And you get 1 minus the probability of not A happening. Why? Because T divided by T gives you 1, and n, a minus sign stays the same, and n of not A divided by T is just the probability of not A, using this definition, right? So you get this expression, 1 minus the probability of not A. Alright, so let me show you an example. Suppose I flip 2 coins, right? What is the probability that I get at least 1 head? Well, let's think about it. Let's flip 2 coins. So the first coin, if I flip it, I have 2 options. I can get a head or I can get a tails. So this is the first coin. Now, from my second coin, let's assume I get heads. For my second coin, I can either get a head or a tails. Or let's suppose I flip a tail on my first coin. Then in the second coin, I can flip a head or I can flip a tails. So I can either flip heads, heads, tail heads, or tails. So I need to look for the probability that I have at least 1 head. So we have 3 such cases, right? So our answer is going to be 3 over 4. But another way to look at this is that P, at least 1 head. So if you go back to the new definition that we just wrote here, the probability of event A is 1 minus the probability of event not A. So P, at least 1 head, is 1 minus the probability of not at least one head. And let's think about what this means. 1 minus probability of not at least one head. So that means you don't even have one head. And that just means no heads. Right? And how many scenarios, and this is easier to think about because there is only one such case where you have no heads. That is the telltale case. So that is 1 out of 4 total outcomes. You have 1 outcome, 2 outcomes, 3 outcomes. So if you do this, you also get 3 over 4. All right. So that is another way to get the same answer. And sometimes for larger problems, this is easier to think about. All right. So we have discussed two things. So probability of A is equal to the number of outcomes favorable to A divided by the total number of outcomes, or it's 1 minus the probability of not A. So using that, you know that probability of A plus probability of not A. So you can write it as A complement. That means not A. So not A is equal to 1. That just means that either A happens, you have the probability of A happens, or it doesn't happen. And the total probability of it happening is 1, right? So probability of A plus probability of not A has to be equal to 1, right? All right. So now let's go and talk about something that we call mutually exclusive events. So now you've got to remember some set theory, but basically the idea of a mutually exclusive event is that two events are mutually exclusive if and they share no common favorable outcome. All right, so this is the key. So two events are mutually exclusive if they share no common favorable outcomes. That just means that if you have event A and event B, right? So that just means that the probability of event A and B happening together is 0. So that is what a mutually exclusive event is. They share no common favorable outcomes. So A and B can't happen together, right? The probability of A and B happening together is 0. And another way to write this is probability of A intersect B is equal to 0. And that just means that A intersect B is disjoint. It's an empty set. So from set theory, A and B are empty. So if you have to draw this as a Venn diagram, that just means that A and B have no intersections. So now, this makes things easier because if you need to find the probability of A or B, then because they have nothing in common, they have no intersection, that means that you can write this as probability of A plus probability of B. All right, so this holds for events that are mutually exclusive. All right, so this holds for events that are mutually exclusive. And you can extend this for any number of events. So if you have A or B or C or D or and goes on, you just P of A plus P of B and you go on, given that all these events are mutually exclusive. All right, and now you can show all of these using a Venn diagram, right? So for a Venn diagram, if you have something like this is called the sample space. That means it's all possible outcomes, right? You have your event A and you have your event B. So this is event A, this is event B. So this is B, this is A. This intersection here, in set theory notation, can be written as A intersect B, which is just A and B happening at the same time, right? And this orange part, sorry, not this orange part, but this yellow part, all right, so let me just shade it in very quickly. This yellow part is what we call, so the yellow part, right? So the yellow part is what we call A union B, or that is just A or B. All right, and the middle part, this part is A and B, is A intersect B. All right, so now if you just want the outside part, right? If you just want the outside part, which let's say is in purple, which is, so I need to fill in everything actually, but okay, let me try my best to do it as quickly as possible. So it looks something like this, but the purple part, which is the outside part, so the purple part is just going to be, the purple part is just going to be, well, it's the whole thing, right? It's my sample space, which is my whole thing, everything together, my sample space minus A union B, right? The purple area is my whole thing minus the yellow part, which is A union B. So these are things that you may want to remember. Another way to write this is the purple part can be written as not A union B. That means everything outside of A union B. All right, so that just means not A union B, or you can also write it as A union B complement, or you can also write it as A union B dash. That just means that it's not A union B. The purple is outside of A union B, right? All right, so these are just some things that you need to remember. And we're going to be working with a lot of Venn diagrams for this topic, and we're going to develop the ideas as we go on. But one last thing you need to remember is that if events are not mutually exclusive, that means that if A intersect B does not equal to the empty set. So this is called the empty set. And basically what I'm saying is that if two events are not mutually exclusive, then we have this following rule that says the probability of A union B is equal to probability of A plus probability of B minus probability of A intersect B. So that is something you need to remember. And how do we know this? Well, let me just show you very quickly. This is A, this is B, right? We are trying to find the probability of this thing, which is A union B. All right. So probability of A union B, well, we take the probability of A, we add it with the probability of B. And if you looked at it carefully, you saw that this region got added twice, right? But we only needed to be counted once. We need to count this region once, and this middle region once. So this region was counted. The outside region was already counted when we added probability of A. When we add probability of B, this outside region was counted, and this middle region was counted twice. So we need to subtract it once, right? So that makes sense. All right. And these are almost all the ideas that we need to start solving questions. So let's just go ahead and solve some questions here. All right. So, okay. So let me go to the chapter to the answer part so that I can compare as we go on. All right. So find the probability that the number rolled with an ordinary fair die, that means six-sided, and it's a fair dice, that means that the probability of getting any face is very equal, right? So the probability of getting one face is 1 over 6. So the probability of getting 1 is 1 over 6, the probability of getting 2 is 1 over 6, and so on. So the probability that the number rolled with an ordinary fair die is, all right, a prime number or a 4. So let's think about it. Can these two things happen together? Can we roll a prime number and 4? Well, no, because 4 is not a prime number. So these two events are mutually exclusive. So that just means that we can say, hey, the probability of a prime number or a 4 is the probability of a prime number plus the probability of a 4. So what is the probability of a prime number? Well, let's see. We have 1, 2, 3, 4, 5, 6. These are the numbers on a dice, which are the prime numbers. 2, 3, and 5 are prime. So we have 3 over 6 plus the probability of rolling a 4 is 1 over 6. So that is 1 over 6. So that is going to be 4 over 6, which is just 2 over 3. All right, so that is the solution to 1a. It says a square number or a multiple of 3. Let's think about it. Well, is it possible to roll a square number and a multiple of 3 on a dice? Well, no, because the only square numbers are 1 and 4, which are not multiples of 3. So these two events are again mutually exclusive. So you have p square plus p multiple of 3, right? So what is the probability of a square number? You have two numbers that are square, which is 1 and 4. And what is the probability that it's a multiple of 3? Well, you have two numbers, 3 and 6. All right, so it's 4 over 6 once again, which is just 2 over 3. All right, so let me erase things very quickly. It's 2 over 3 for both A and B. Now, let's see. So, more than 3 or a factor of 8. All right, so now, this is a bit tricky because you can't directly add, right? So these two things can happen at the same time. You can roll 4, which is more than 3, and 4 is a factor of 8. All right, so now how do we deal with this problem? Well, to solve for this, it's going to be probability. It's going to be the last thing that we saw. Probability of A union B if they are not mutually exclusive. So this is not mutually exclusive, right? These two things can happen at the same time. So that means that it's probability of A plus probability of B minus the probability of A intersect B. What is the probability that we roll more than 3? Well, it's 4, 5, and 6, right? So that is 3 over 6. What is the probability that it's a factor of 8? Well, there are only 2 factors of 8. Well, technically there are 3 factors of 8, right? Let me search very quickly. So what are the factors of 8? Well, 1 is a factor of 8 because it divides 8 without leaving any remainder, right? 8 divided by 1 is just 8, no remainder. 2 is a factor and 4 is a factor, right? 8 divided by 2 is 4, no remainder. And 8 divided by 4 is 2, no remainder. So you have 3 factors of 8. Minus, now, more than 3 and a factor of 8. Well, that's only one possibility, which is rolling a 4. So that's minus 1 over 6. And that gives you 5 over 6. That is going to be your solution. All right. And we're done. So we need to use inclusion-exclusion. So this is also called inclusion-exclusion to solve some of the problems. And we are done with 1. All right. So I think it's better if I screenshot this and solve it on the other side. So let me screenshot this and we're going to solve 2 and 3. Alright, so let me lock this image so that it doesn't move. So question 2, a group of 40 learners took a chemistry test. And it says the following Venn diagram shows that 19 boys took the test and that 7 learners failed the test. Alright. So this stands for boys and 16 boys took the... So let me show you what this means in context, right? This first circle is for boys, B, and the other circle is for the ones that failed. Alright. So now we know that there are 19 boys who took the test. So why do we only have 16? Well, if you add these two numbers together, you get 19. That means that these 3 boys, they took the test and they also failed the test. So they are in between. They satisfy both the conditions. 16 are boys who took the test and passed. 4 are kids who failed, right? They are not boys, they are girls. So they are not boys and they failed the test. And then there are 17 children. 17 who are neither boys and did not fail as well. So they are girls who passed the test. So it says, describe the 21 learners who are members of the set not B. Alright. So what is B? B is boys. What is not B? If B is this area. What is not B? Not B is everything outside, right? And what does not B describe? It just describes the girls who took the test. So it doesn't describe girls who took the test and passed, because this failure portion is also a part of not B, right? It just describes girls. It just describes girls who took the test. All right. So find the probability that the randomly selected learner is a boy or someone who failed the test. Now, are these two events mutually exclusive? No, because you can be a boy and fail the test. So this is inclusion exclusion again. So it's probability of being a boy plus probability of failing. So we're asking a boy or someone who failed the test. So PB union F. Or means union and means intersect. So this is equal to PB plus PF minus PB intersect F. All right. So what is the probability that we have a boy in the class who took the test, right? So we have 19 boys out of 40 students. Plus the probability of people who failed. So that is just 7 out of 40 who failed. Minus you are a boy and you failed. And we know that exactly 3 students satisfy that condition. So if you do this, you get 23 over 40. That is your probability. All right. So we're done with question 2. Question 3. The following table gives information about all the animals on a farm. So we have 5 male goats and 3 male sheep. We have 25 female goats and 22 female sheep. All right, because the plural of sheep is still sheep. Find the probability that a randomly selected animal is male or a goat. All right. So again, you can be male and a goat, right? You can be a male goat, basically. So this is an inclusion-exclusion question again, because these two events are not mutually exclusive. So this is the probability of being male plus the probability of being goat minus the probability of being male and a goat. Basically, the probability of being a male goat. So what is the total number of animals? Well, you have 30 goats, right? And you have 25 sheep. So basically 55 animals. So what is the probability of being male? The probability of being male is just 8 over 55. You have 55 animals and 8 of them are male. What is the probability that you are a goat? You have 30 goats. So 30 over 55. Minus the probability of a male goat, which is 5 over 55. So that gives you 8 plus 30 minus 5 is just 33 over 55, which is 3 over 5. All right, so that is 1. A sheep or female. Again, these are not mutually exclusive. So this is equal to probability of sheep plus probability of being female minus probability of being a female sheep, right? Female sheep. Basically, sheep and female. That means a female sheep. So what is the probability that you are a sheep here? So that is 25 over 55. What is the probability that you are female? Well, it's this sum. 22 plus 25. That is 47 over 55 minus the probability that you are a female sheep. And that is 22 over 55. And if you do the addition, minus 22, you'll get 50 over 55, which is just 10 over 11. All right, so we are done with 2. Now it says, find a different way of describing each of the 2 types of animal in part A. All right, so basically it says, find a different way of describing each of the 2 types of animal in part A. So 1 says male or a goat. So that means we want, so you are either male or you are a goat, right? You don't want both. You want either a male or a goat. So basically that means not a male goat. You don't want both. A sheep or female. That means not a female sheep. Basically, it just means not a female sheep. All right. question 4. So let's go and find question 4. Let's do 4 and 5 together, or maybe 4, 5, and 6. All right, we'll copy this and we'll paste it here. All right, question 4. 2 ordinary, so we have 2 dice rolled. All right, and the 3 events are: the sum of 2 numbers rolled is 6, the difference between the 2 numbers rolled is 0, and both of the numbers rolled are even. All right, list the outcomes that are favorable to x and y, x and z, and y and z. All right, so now how do we think of this? When we have 2 dice, it's easy to think about the outcomes. So I'm going to think about the outcomes in a tabular form. All right, and basically I'm going to have my first die here. So 1, 2, 3, 4, 5, 6, and I'm going to have columns as well. And I'm going to have my second die here. 1, 2, 3, 4, 5, 6. So I can roll numbers 1 through 6 on each die. So what are the possible combinations I can get? I can get 1 and 1. I can get 1 on the first dice, 2 on the second dice. I can get 1 and 3, 1 and 4, 1 and 5, and 1 and 6. All right. I can get 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, and 2 and 6, and so on. So 3 and 1, 3 and 2, 3 and 3, 3 and 4, 3 and 5, and 3 and 6. And I can get 4 and 1. So basically, let me just complete the table. Alright, so we have completed the table. Now, event x is the sum of the 2 numbers rolled is 6. So we want the outcomes that are favorable to x and y. So difference between the 2 numbers rolled is 0. Alright, so let's look at the numbers that add up to 6. The outcomes that add up to 6. Well, 1 and 5, right? 1 and 5 here. This adds up to 6, and symmetrically 5 and 1 will also add up to 6. All right. 2 and 4 add up to 6, and symmetrically 4 and 2 add up to 6, right? And from this, 3 and 3 will add up to 6. From the last row, nothing adds to 6 because 6 and 1 already is 7. And I think that is it. These are all the possible combinations that add to 6. And the difference between the 2 numbers rolled is 0. Now let's see from these green ones, which gives me a difference of 0. 5 and 1, that is 4. 2 and 4, the difference is 2. This difference is 0. 4 and 2, the difference is 2. 5 and 1, the difference is 2. So the only number that satisfies x and y is just 3 and 3. Alright. So that is the only one. Now x is the sum of 2 numbers rolled is 6. So we're going to go back to looking at our green ones. And it says z is both the numbers rolled are even. Okay, let's see. So we go here. Both of these are odd. These are even. And this are even. The rest is all odd, right? So 2, 4, and 4, 2. 2, 4, and 4, 2. These are the 2 favorable outcomes. And it says y and z. So the difference rolled between the 2 numbers is 0. So for that, we just need to look at our diagonals. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. The difference between these 2 numbers are 0. And both the numbers rolled are even. Well, that is 2, 2, 4, 4, and 6, 6. So we have 3 outcomes. So for y and z, we have 2, 2, 4, 4, and 6, 6. All right. So that we are done with A. And it says, what do your answers to part A tell you about the events X, Y, and Z? That means that they are not mutually exclusive. How do I know that? Well, because the probability of X and Y happening is not zero. There is a common outcome to all events, right? So X and Y, these are not mutually exclusive. X and Z are not mutually exclusive, and Y and Z are not mutually exclusive. So that just means that they have a common favorable outcome. All right, so we are done with 4. Question 5. The letters A, B, 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 C, D, D, and E are written onto 8 cards and placed in the back. Find the probability that the letter on a randomly selected card is a vowel or in the word domain. All right. So can we have a vowel and it is in the word domain? Well, yes, right? We don't have an I, but we have an A in domain. We don't have an O here, but we don't have an O and an I, but we have an A here, and A is in domain. So basically, the probability is going to be, or means probability of vowel or domain is going to be probability that it is a vowel plus probability that it is in the word domain minus the probability that it is a vowel and it is in the word domain. All right, so what is the probability that we draw a vowel, right? Well, we only have one vowel, which is A here. And then how many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8. All right. So 1 out of 8 is a vowel plus. What is the probability that these letters are in domain, right? So what letters are in domain? D, D, and A are in domain, right? B, C, and E are not in domain. So the probability that a letter is in the word domain is 3 over 8, right? Now, what is the probability that we have a vowel and it is in the word domain? Well, A is a vowel and A is in domain, so it's the only one. Minus 1 over 8. So your overall probability is going to be 3 over 8. All right. Oh, sorry. We have 2 vowels, right? The probability of drawing a vowel, we have 2 vowels. A and E are vowels here. So it's actually 2 over 8. So everything gives you 4 over 8, which is just 1 over 2. All right, so I missed this E here. So the probability of drawing a vowel is 2 over 8. The probability that drawing a letter that is in the word domain is 3 over 8. And then the probability of drawing a letter that is both a vowel and in the word domain is 1 over 8. So you need to subtract it off. All right, so you get 1 over 2. And the second says it's a consonant or in the word double. So can we have a consonant? Are these two events mutually exclusive? No, because there is an intersection. They can happen at the same time. So we need to do the same thing. It's the probability that it is a consonant, the probability that it is in the word double, minus the probability that it is a consonant and in the word double. All right. And let's just look at what is the probability that it is a consonant. Well, how many consonants do we have here? B, 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 C are all consonants. So 4 out of the 8 letters, sorry, D is also a consonant. So 6 out of the 8 letters are consonants. Plus, how many of these are in the word double? Well, E is in double, B is in double, and D is in double, right? So 1, 2, 3. So 1, 2, 3, 4, 5, 6. All right. 6 over 8 minus we have a consonant that is in double. So aside from C, D and B are consonants in the word double. So minus 4 over 8. Sorry, minus 5 over 8, right? Because we have 2 D's and 3 B's. So we have 5 consonants that are in the word double. And if you do everything, you should get, this is 12 over 8 minus 5 over 8 is just 7 over 8. And that is your solution, 7 over 8. All right. Question 6. In a group of 25 boys, 9 are members of the chess club C, and 8 are members of the debating club, and 10 are members of neither of these clubs. The information is shown in the Venn diagram. So 10 boys are neither in basically they are not in chess or debating clubs, right? So in a group of 25 boys, so everything, when you add everything together, it should add up to basically 25. All right, and 8 are members of debating clubs. All right, so that just means that B plus C together should give me 8. And similarly, A plus B should give me 9, right? Because total number of boys in the chess clubs are 9. All right, and we know that, hey, ten of them are in neither, right? So we know that A plus B plus C plus 10 is equal to 25. Because total number of boys should be 25. So some of them are only in the chess club, some of them are only in the debate club, some of them are in both, and 10 of them are in neither. So basically, adding everything together should give me 25. And that just means that A plus B plus C is 15, right? And A plus B I know is 9. So 9 plus C is 15. C is equal to 15 minus 9, which is equal to 6. Alright, so I know that 6 of the boys are only in debating clubs. And basically, once I know this, I know that 2 boys must be in both, because 6 plus 2 must give me 8. And basically, if I know that, then I know that, hey, 7 boys must be only in the chess club, because 7 and 2 must add up together to give me 9. So A is 7, B is 2, and C is equal to 6. Those are going to be your solution. Alright, find the probability that a randomly selected boy is a member of the chess club or the debating club. So basically, again, these are not mutually exclusive. So it's probability of chess plus probability of debating minus the probability of chess, and we can write it as intersection debating. So what is the probability that a boy is in the chess club? Well, it's 9 boys in total in the chess club over 25. What is the probability that they are in the debating club? Where it's 8 boys minus there are 2 boys who are in both. So you get 15 over 25, which is 3 over 5. 5 3s are 15, 5 5s are 25. All right, a member of exactly one of these clubs, right? So basically that means that you can't be in neither, right? You have to be in at least one of them. You have to be in either the chess club or the debating club. And you can't be in both because it says exactly one of these clubs. So basically it's this A plus C, right? So it's A plus C divided by 25. So A is 7 plus C is 6. Is 13 over 25. And we are done. Alright, so we'll continue more in the next video.